Hi, Kevin Culp here, back at you at Super Micro. We're continuing our podcast on building out our virtual machine infrastructure to support our applications in our user community and the enterprise. So we had a previous video that really discussed how quickly and easily it is and effectively to push out VLANs to a top-of-rack switch. With a couple of clicks, we showed you here, based on SuperCloud Composer and its lifecycle management, to do top-of-rack switch provisioning of those VLANs to be presented for our third-party switch integration with SuperCloud Composer. So at this point, we've passed the baton over to the server architect, where the server architect is now taking in the lead role to continue on provisioning the virtual machine traffic. So I'm taking on that role today of supporting the server architect side, showing you how you quickly can build out a virtual machine infrastructure to support your enterprise requirements. So the first thing here is we're looking at logged into the KVM HyperVisor through PuTTY. And the first thing we want to do is really dig deep into say, well, gee, how did we configure these interfaces for .1Q trunking? How did we configure bridging for our virtual machines to actually connect to? So as I mentioned in a previous video, is where we store the information of the scripts is in etc, sysconfig, and then network scripts. And here we have basically, excuse me, those network scripts that are available to us. So you'll see here, based on 100, 200, and 300, and 672, those are represented as tagged interfaces that we basically presented within our KVM HyperVisor. The 672 VLAN is really there for me to manage my particular hypervisor, to allow me to interconnect inbound through SSH to really manipulate and manage my hypervisor itself. So it's really the management VLAN that we are basically looking at from building our KVM hypervisor. VLANs 100, 200, and 300 is where we will actually present our compute traffic. So our virtual machines will ride on top of those particular VLANs and interconnect to each other. And we'll show you that a little bit later through pings of how reachability exists between CentOS machines, Ubuntu, and also Microsoft basically machines. The other aspect of this is bridge 1, 200, and 300 is where we build those bridges for those virtual machines to interconnect to. So we have what we call VNICs that are on those virtual machines that need to connect to the V port of the bridge to make that electrical connection, so that traffic is basically flowing up to our hypervisor and eventually out onto the internet to pull down software dependencies that may exist in regards to some of our platforms that we're provisioning in our custom demo lab. I mentioned 24 F0 and F1. Remember earlier we actually utilized those interfaces through an LACP port bond to connect into our backend storage through NFS. So those interfaces we talked about previously in our video. So I'm going to actually start with looking at essentially what we call the 100 interface itself. And if we cat out that file, cut and paste it, we immediately see the first line that's obvious to us is there's VLANs here. VLANs, yes, means that we're participating in a tagged particular frame. There's a VLAN that's associated with this. If we were provisioning a VLAN such as an access port, we would never use the VLAN parameter associated with our interface because it would be connected to what we call the native VLAN, or basically an access port that is untagged. We'll go down to the other parameters here for boot protocol none enum control, no. Bridge 100, and on boot, yes. So we never define an IP address on the actual tagged VLAN. It's done at the bridge level. So we'll show you that a little bit later in each one of those configurations. So we're going to use the up arrow key. We're going to change it to 200 and see what we see for the 200 script. The 200 script is identically the same for a couple of changes. First of all, it's really named .200, right, to indicate it's participating in VLAN 200. And also the device is set for 200. And so this is a mechanism within basically Linux to let you know that this particular interface, which is 200, is basically tagged, and it is connecting to a bridge 200 type of bridge. So is it recommended that you go ahead and potentially configure LACP on your compute traffic? Yes. For our particular example, we're using only one uplink. We have a very small network to represent our virtual machines, but when you're dealing with lots of virtual machines and you want to improve on the bandwidth and that that particular uplink may be overrun, you will basically configure port bonding, the same concept that we talked about earlier, to create a port bond. That port bond may be depending on what traffic patterns you have and what kind of traffic you're actually sending across those links. Perhaps it will be 10 gig that you're going to bond, say, 4 particular 10 gig interfaces to get an aggregate of 40 across that link. And there may be situations where you're adding a number of VLANs across that .1Q trunk, at which point in time it's important to basically create an LACP port bond to support that initiative. So let's move on to 300. So 300 should not be any different here. Just the fact is that we're now presenting VLAN 300. It's tagged and it's associated with bridge 300. So those are the 3 interfaces that we have configured. So let's clear it, and then look at other information we want to look at. So we want to look now at what we call the bridged interface, or the bridged particular script that we have created. We'll cut and paste it in, and then take a look at the actual script that relates to the bridge. So you'll notice here the device has now changed to BR100. That is the reference point back into the tag VLAN interface. It is now a type of bridge, and its IP address is in a subnet we created in VLAN 100. Our virtual machines will be in that particular subnet of 192.168.0/24 bits as a subnet. We happen to create this IP address of this interface to be 254. Our net mask is 24-bit. And our gateway, where I see a little bit of an error message here, is in regards to, I need to make a change here because we have incorrect information here. I noticed our gateway has a problem with it. So let's make the change now. It's missing the Y there, which it's funny that our parser didn't pick that up. And let's now look at it and see if it's correct. Okay, so now it shows as a gateway properly with the Y at the end. Let's just go back and double check our 200 one. It's missing 2 as well, so why don't we make that change as well to show you through VI. We'll make that change. I for insert, Y escape, shift, :WQ bang to save it. And then we'll also do that for 100. Make sure, and 100 is set correctly. Q bang Let's look at 300. And 300 is missing the Y2. Let's make that change. I for insert, Y escape, shift, colon, WQ, bang. All right, so let's just look at each one of them to make sure they're set correctly. So BR300 is correct, 200 is correct, and also $100 is correct. All right, so we've created our bridge environment to show you the bridges that are connected themselves, we also need to show you how they're actually configured. So we can do an add adder, show grep, and then BR. It'll show us all the bridges that are up. So bridge 200 is up, bridge 300 is up, and also bridge 672 is up, and so on and so forth. So let's clear it out, and let's go ahead here and look at our IP address interface for our interfaces themselves, grep enp. And we see here where we have 100 configured, 200 configured, 300 configured, and 672 configured. So each of these are tagged interfaces. And remember, our 24s are part of our bond, and they show up as bond 0. That's where we're sending our storage traffic through that physical link. So we have these completely partitioned, compute traffic on one set of NICs, and also storage traffic on another set of NICs. So this is sort of best practice we do. We want to combine the compute traffic with basically the storage traffic itself. So that is a nutshell our configuration of .1Q trunking and also bridging. The next particular thing we're going to show you is a verse command, a verse list, to show you basically all the VMs that are there. We have 3 of them, 4 of them that are sitting in a shut off state. So we could basically start those VMs up from the console connection themselves through our command line interface and connect to them. But I'm going to show you a much easier way through the desktop to be able to control your virtual machines. Of course, if you're doing any type of scripting, you would be utilizing the CLI to write a bash script or some type of script to be able to manipulate the states of each of these virtual machines and be able to alter the XML file to connect to certain networks and so on and so forth. I'm going to show you a very basic way to do this, easier to navigate through. For advanced users, they would be looking more from a bash scripting capability to be able to manipulate essentially the systems themselves or your virtual machines. That's all I have for this particular video podcast. Thank you for joining. We'll see you next time.